So this is section 0.4 called zeros of a function, and it is very important that you have this algebra skill from one of your previous algebra classes, because we're going to be setting functions equal to 0 an awful lot. In fact, we're going to be setting the derivatives of functions equal to 0 and looking for what we're going to call critical values. So being able to take a function and figure out where it equals 0 is the first step in doing what we're going to be doing, which is finding maxes and mins of functions. So I listed the ways that you can do that in Math 110. Factoring is often the fastest, easiest way to do that if you have a quadratic that factors, which means you wrote it in a way that it looked before somebody FOILed it out. That's what factoring is. Completing the square is an option that's not often used because number 3 is the quadratic formula, which comes from somebody completing the square on a general quadratic, and so we can use it as a rule, a way to plug in and find the zeros of a function. And then finally, if you have a graphing calculator, you can use your graphing calculator. So there are ways that the graphing calculator can find zeros for you quickly, and I'm fine with you doing that. If you don't know how to do that, I mentioned it in the first day of class, and I can help you one-on-one how to use your graphing calculator. One thing that we want to remember is that if you have a quadratic formula or a quadratic equation, it's possible that you'll find no real zeros, 1 real zero, or 2 real zeros. Those are the possibilities. And we're only interested in real zeros in Math 110. So in Math 22, we found all the zeros, and some of them were imaginary. We're going to disregard all the imaginary answers because we're interested in looking at the graph of the function, and the graph of the function wouldn't have any imaginary roots on it. So as we look at these problems, if it's an imaginary solution, we're just going to disregard it. So what I mean by that is you might have the quadratic equation y equals x squared plus 4, let's say. And if that's your quadratic equation, it graphs like a parabola that's moved up 4 units. And zeros are where we cross the x-axis, and if you look at x squared plus 4, there are no zeros to it because there is no place where it crosses the x-axis. The roots to this, if I set it equal to 0, would be imaginary, and we are not interested in that. So in Math 110, we're going to say x squared plus 4 can't equal 0. And what we mean by that is there are no real numbers that would make that happen. So the importance of finding zeros, like I said, for the most part it's going to be once we take the derivative, but it's also important to know in terms of business calculus that the point of intersection of two graphs is something we're interested in, and it is if we're talking about a break-even point. So break-even points are points where our revenue and our cost have the same value, and that means that we would be making as much money on the product as it cost us to make the product. And that's sometimes a good place to know, like how long will it take me so that my revenue, the money I'm pulling in, matches the money I already put out in my production. So in order to find a break-even point, you would need a revenue function, which I'm giving here as 32x, which means that you're making $32 for every product that you sell, because x is going to stand for that. And in this case, x is given in thousands, but we're going to just say 32 times x will be our revenue, and we'll remember that if x is 3, that means 3,000 subscribers. And cost, there's a fixed cost involved here, $195, and a variable cost, which is $12. So our fixed cost and our variable cost are the two pieces that we have to put together here. And what fixed cost means is if I didn't even make any units, I just decided to go into business. So I went out and bought everything I needed to go into business, and then I shut the door and didn't make anything. I would still have $195 that I have paid out. So I'd be in the hole $195. Then if I decide to start making products, then the variable cost takes over. So every product I decide to make is going to cost me $12. And that's the two pieces of our cost function that we want to take into consideration. So we won't have broken even if we don't make anything, because our revenue will be 0 and our cost would still be $195. So we want to find that magic number that makes revenue and cost equal to each other. And in this simple situation, since they're both linear, it would look like this algebraically. And so we'd say 32x equals 195 plus 12x. We'd subtract 12x from both sides. And then we divide 195 by 20. And when we divide 195 by 20, we're going to end up with a decimal answer because 20 doesn't go into 195 evenly. So we want to make sure that we remember that x is, in this case, given in thousands of subscribers. So when we take 195 divided by 20, and I don't have my graphing calculator with me, so I'm going to do it on my phone. 195 divided by 20 is 9.75. So I would say 9.75, and then I would multiply that by 1,000 to give the answer. 9,750 subscribers would make me break even. So break even point, we're setting two things equal and looking for that equality. And that actually is similar to finding a 0 of the function. So in terms of how would it look to find a 0 of the function, you would want to know that profit is revenue minus cost. So if we had taken these two functions and we had actually turned them into a profit function by subtracting them, we could then think of setting profit equal to 0, because our profit function would be 20x minus 195. So the 0 of our profit function would be the same as setting revenue equal to cost, and we get the same answer. In terms of factoring, it is important that you know how to factor. Not necessarily to find zeros, because there's other ways to do it, but once we get into limits, factoring is going to be a big piece of it. So I just put a couple different reminders from Math 21 about factoring. If you have the difference of two perfect squares, you can factor that into one of the, whatever this term is before it was squared, plus whatever this term was before it was squared. And the other factor is those two with a subtraction in the middle. So x squared minus 36 is x plus 6 times x minus 6. Sometimes there's a middle term. So that's what this would look like. If I had a squared plus or minus, it doesn't matter which, 2ab plus b squared, it can factor into what we call a perfect square trinomial. So that would look like if I had x squared plus 4x plus 4. In that case, a is x and b is 2, and this is 2ab here. And so then I would factor it into x plus 2 quantity squared. So sometimes things factor that way. And then the third one that's often forgotten is the difference of two perfect cubes. So if you have two things that are perfect cubes, you can factor that into a binomial times a trinomial. And this little word SOAP is a way to help you remember the signs for that. So whatever this is, if it's a perfect cube, I'm going to start with the cube root of it. And whatever this is, I'm going to start with the cube root of that. And I'm going to use the same sign that was in the problem. So that's what this plus minus means. Whatever this sign was, this sign will be. That's why S. Then I'm going to square whatever I put first. And I'm going to use the opposite sign. So that's why this is turned upside down. O stands for opposite. Then I'm going to multiply together whatever A and B are, put it in the middle. This is always positive. That's why it just is a plus, always positive. And then we're going to square whatever we put in for B. So that could look like this, x cubed plus 27. They're both perfect cubes. What you want to know is the signs go plus, minus, plus. Same sign, opposite sign, always positive. You look at x cubed and you put an x here. You look at 27 and you put a 3 here, because those are the cube roots. This is x squared. In the middle is the product of the two, x times 3. And lastly is 3 squared, which is 9. And that's how you factor the sum of two perfect cubes. And if this had been a minus, then this would be a minus, and this would be a plus. Those would be the only changes, because this is always positive. So that's just a quick review of factoring. But what the most important thing that we have to do in Math 110 that you probably have not done before, or definitely not done a lot before, is factoring out the common factor, which sounds like a really simple thing. Seems easy. Factoring out the common factor, you might think 2x plus 6, factor out the 2. Very simple idea. You're just taking 2x plus 6 and dividing each term by 2. And putting the 2 outside so that it could distribute back in. This gets more complicated, but same idea as we move into 110. Sometimes we have to factor out negative or fractional exponents. And in that case, we are always going to look for this general rule of thumb, that is, find the lowest exponent and factor it out, no matter what. So what that can look like is, here's some problems that I'm calling building the skill, because it is a skill that once you get the hang of it becomes very simple, and it's extremely useful in Math 110. So to build the skill here, we want to look at problems that are very easy and work toward problems that are substantially more complicated, keeping in mind our goal. And our goal in this is always to factor out any constants that the two terms have in common and the lowest degree of any variable that we see. So when we look at 2x plus 8, we compare the 2 and the 8 and factor out a 2. And then we look at the x and the fact that there are no x's here, and that means that we are not going to factor any x's out, because the lowest degree on x is 0. This is x to the first, this is x to the 0. So if there aren't any x's, that means we don't factor any out. So we're going to leave it as 2. And then what goes in here, we take 2x and divide it by 2. And that's why we put an x here. And we take 8 and divide it by 2. And that's why we put a 4 here. So the answer of what's left inside the parentheses is a division result. It comes from dividing the 2 into both of the original terms. Because we check by distributing, which is multiplication, we are getting our solution by division. So, same idea here. We'd look at 3 terms and we'd say, okay, all 3 of those terms are divisible by 3. 3 is a common factor that I want to factor out. Then we go to the x part of these terms, the factor, and look at x to the third, x to the second, x to the first. So we're going to choose to factor out x to the first, the lowest degree. And what's going to be left is 3x to the third divided by 3x. And when we divide, we subtract our exponents. So that's why we're left with x squared. 6 divided by 3 is 2. And x squared divided by x, we subtract our exponents and we have x to the first. And 9x divided by 3. So 9 divided by 3 is 3. X divided by x is no x's. So I know that seems pretty simplistic, but we want to think through what we're doing, because now we're going to look at a problem that you might not have seen before in terms of factoring out, and that is when you have a fractional exponent. So we're still going to compare 1 and 1/2, and we're going to choose the lower of the two to factor out. So we're going to factor a 4 out because of 4 and 8. We're also going to factor out the lower exponent, which is x to the 1/2. And what we're going to be left with is 4 divided by 4 is 1. X divided by x to the 1/2. Well, we're supposed to subtract our exponents, and that means we're going to get x to the 1/2 because 1 minus 1/2 is 1/2. And then 8 divided by 4 is 2. 1/2 minus 1/2 is 0, so there aren't going to be any x's left in that last term. So we can factor out a fractional exponent, and there are going to be times where we want to do that. We can factor out a negative exponent. So here, 5 and 15, we'll pull out a 5, and when we compare 1 and -1, we want to factor out the lower of the two. So we're going to factor out a -1, and now we're going to go decide what's left. So we've got a subtraction sign here, and on the left of it, we're looking at this term. 5 divided by 5 is 1, and now we got to decide what to do with the x's. Well, what we do is subtract the exponents because we're dividing. So 1 minus -1, and that actually is 2. So what we're left with here is an x squared. So when we factor out a negative exponent, the exponents that are left actually increase because we're subtracting a negative. So this becomes x squared, and then we divide 15 by 5, which is 3. -1 minus -1 is 0. So we have no x's left here because we factored out the exact exponent from that second term. But now you can see that you could find a 0 from that. You could figure out what values of x make this quantity 0 because you could set that equal to 0. And that's our goal, is when we have these negative exponents and we factor them out, what's left is going to help us find the zeros. So looking at the third one, same idea, just 3 terms instead of 2. We're going to take a look at 24, 8, and 16 and factor out an 8. We're going to take a look at x cubed, x to the -2, and x to the 4, and we're going to choose the lowest of those 3 to factor out. And now we're going to do one by one. We're going to look at each term. We're going to take 24x to the 3rd divided by 8x to the -2. So 24 divided by 8 is 3. 3 minus -2, because when we're dividing, we subtract our exponents. 3 minus -2 is 5. Then we move to the next one. 8 divided by 8 is 1. -2 and -2. So we subtract the exponents, we have no x's. So we move on to the last term. 16 divided by 8 is 2. 4 minus -2. That's 6. So we factored out the lowest degree, and we were left with all positive exponents, except for here where we didn't have an x at all. So factoring out fractional exponents, factoring out negative exponents. And the last thing that we want to talk about is, what do you do if you have fractional coefficients? And we're trying to make this part of the problem as simple as possible. So in other words, we're trying to take all of the complicated stuff out and put it out front. And it'll be clear why we're doing that later on, but that's our goal, is simple in here, complex out here. So when we look at 1/3 and 1/2, we would like to take out the fractional part of that. Factor out a fraction that they both have in common. And the only way to determine that is to think about them with a common denominator. So I'm going to do this step here where I'm going to think about 1/3 in terms of sixths, because I could turn both of these denominators into 6 pretty easily. This one I turn into 6 by multiplying it by 2 halves. So I'll call that 2/6. And this I could turn into 6 by multiplying by 3/3. So I'll call that 3/6. And so I'm just renaming our fractions so they have the same denominator. And now I can look at these and say, these two terms both have this common idea of 1/6, the 6 in the denominator. So I could divide them both by 1/6, and that will get rid of the complexity in here. I also can factor out an x squared because that's the lowest degree. And once I pull the 1/6 out of this, I'm going to do 2/6 divided by 1/6, and if you need to use your calculator, that's fine. But really, when you're dividing 2/6 by 1/6, you can divide the numerators and divide the denominators and realize you're just going to get 2. And this exponent minus x exponent means x to the 0. There aren't any x's. Minus 3, because for the same reason, 3/6 divided by 1/6 is 3. Subtract your exponents, you get x. So now looking at that problem, you can say, oh, I can see what value of x would make that equal to 0. Be very easy to see that. And that's our goal, is to make it simpler to find zeros by factoring. So those are the pieces. We've got fractional exponents, negative exponents, and fractional coefficients. And they're going to take us into these next problems, which look a lot more complicated, and they are. But once you get the hang of it, you'll find that it's not as bad as it looks as long as you take it step by step, the same way we did 2x plus 8. So we're going to focus on the subtraction, and we're going to decide what is it that we could take out here that both of these terms have, and then what should we leave here because it's extra from this term, and here because it's extra from this term. So we're going to try to stay in order here. 4 and 8 we could factor out, and if you notice, they're both negative. So we could actually take out the complexity of the negative as well as that common factor of 4. Then we focus on our x's, and we take the lower degree, which is square, and then we focus on our y's, and we take the lower degree, which is 5. So now I'm going to look at this and divide it by that, and whatever's left is going to go right here. So negative 4 divided by negative 4, nothing left. X cubed divided by x squared, I'm going to subtract my exponents, 3 minus 2, and I'm going to have an x left. And y to the 5th divided by y to the 5th, when I subtract my exponents, no y's. Move over to the other side. This is a negative 8 divided by a negative 4. So I'm going to actually have a positive 2 left. Because I pulled out the negative, this is going to have to turn positive. X squared divided by x squared, so no x's left. And y to the 6th divided by y to the 5th, subtract your exponents, there's a y left. And so the same thing is going to happen if we get fractional exponents. Exactly the same idea. We're going to have something left on the outside, and then we're going to have whatever is extra that we haven't taken out is going to go in here in the same order. So 18 and 9, we're going to pull out the common factor of 9. X to the 1/2 and x to the negative 1/2, we're going to make sure we pull out the lower of those two. And y to the 3/2 and y to the 5/2, the lower of those two. So a common mistake when we go into here is to think that the x has got to be left first and the y has got to be left second. That's not necessarily true. We have to look at each problem on its own to figure out what's left where. So we want to only focus on this first piece here. and we want to just take 18 divided by 9, x to the 1/2 divided by x to the negative 1/2. So I'm going to subtract my exponents. 1/2 minus negative 1/2 is 1. So I'll have an x left here. And y to the 3/2 minus y to the, or divided by y to the 3/2, when I subtract, I realize there's no y's left. Moving to the other side, 9 divided by 9 is 1. So I can put it or not. X to the negative 1/2 divided by x to the negative 1/2 means no x's. Y to the 5/2 divided by y to the 3/2, 5/2 minus 3/2 is also 1. So my y is left there. So I've simplified it by factoring out all the complexity. And then that also leads us to this section here, where we can say the same thing is going to happen. We're going to look at both sides of this subtraction and look for what is in common on both sides. So you can imagine this could just be an x and this could just be a y. And then if this is an x, so is that, because they match. And if this is a y, so is that. So it's not any harder than the problem above it. It's just that you've got to clump this together in your mind as one thing and clump this together in your mind as another thing. And so when we decide what's going to be factored out and what's going to be left in, what's going to be factored out is this factor to the lower of the 2 degrees. In this case, negative 3. And then we're going to look at the other factor, which is 2x plus 1, and pick the lower degree, which in this case is 2. Now we're going to move inside, and we have subtraction. So we're going to look on the left of the subtraction and compare and divide. X plus 2 to the negative 3 divided by x plus 2 to the negative 3. And that means there are none of these factors left, because negative 3 minus negative 3 is 0. So right here, I'm not going to have any x plus 3 factors. But when I look at the other one, 2x plus 1, and I subtract 3 minus 2, I'm going to have a 2x plus 1 left. So that's what I meant by don't assume that because these are in this order, that when you go inside your parentheses, this has to be x plus 2. It's not. You always just put in here whichever one is left after this is divided out. So in that case, it's the 2x plus 1. And then we move to the other side of the subtraction, and we do the same thing. We're going to divide x plus 2 to the negative 2 by x plus 2 to the negative 3. So we're taking the exponent here minus the exponent there. And that's telling us that we actually do have an x plus 2 factor left. And it is to the first power. But the 2x plus 1, when we divide 2x plus 1 squared by 2x plus 1 squared, we don't have any 2x plus 1 factors left. So it is just this left inside. So we took out the complexity, and we're left with something fairly simple inside. And the only thing left to do is to subtract to simplify what's inside here, because we can actually simplify this. We couldn't simplify it before. There was nothing we could do here. These were not like terms, but these are like terms. So I have my x plus 2 to the negative 3 that I factored out. I have my 2x plus 1 squared that I factored out. And now I'm going to have, when I distribute my negative, a 2x minus an x, which is called x, and a 1 minus a 2, which is negative 1. So we have to distribute our negative, make sure we do that, to figure out how to simplify this. All right, so you might want to turn the video off for a minute and try this next one on your own. That might be a good idea to make sure that you really get it. But I'm going to run through it right now. So I suggest that you always try it first on your own rather than listening to me do it again. But that's up to you. So I'm looking again at my subtraction and what I'm going to factor out. And I know I have 3x plus 5 is one of the terms that I see. And I want to choose the lower degree, which is 3. And x minus 6, and I'm going to choose the lower degree, which is negative 4. So now I'm going to look at this first piece here and divide. So I'm dividing this 3x plus 5 to the third into that. And when I subtract the exponents, I have a 3x plus 5 left here. 4 minus 3 is 1. But negative 4 minus negative 4 leaves me with none of the x minus 6 factors here. Then I move on to the second one. Dividing, I subtract 3 minus 3 and realize there are no 3x plus 5 factors left. Negative 3 minus negative 4 is 1. So I have x minus 6 to the first left here. Then I go to simplify. I have my 2 factors that I pulled out. And then I have my answer after I distribute. 3x minus x, 2x. 5 minus negative 6, 11. So that is how we build the skill to simplify out our common factor. And the final thing in this section is trying to get a common denominator to solve a rational expression. So if you're trying to solve this equation, setting it equal to 1, and figure out what value of x is going to make that happen, sometimes the easiest way to do it is to use the idea that if two fractions are equal, if you multiply on the diagonals, the result should also be equal. The problem is I don't have two fractions equal here. I have this thing equal to the number 1. So one thing I could do is pull this together and into a common denominator. And the way that I can do that is if I have a over b and I'm trying to add c over d to it, so two fractions added together, I multiply the denominators, and then I take this numerator times that denominator plus this numerator times that denominator. So that's my rule. And what it would look like in this case is x times x minus 1, and then I take 3 times x minus 1 by distributing, plus 8 times x. So I pull those two fractions together with a common denominator. I can rewrite the top as 11x minus 3, and the bottom as x times x minus 1 still. And now, if I want to use the rule that when two fractions are equal, the diagonals multiply to the same thing, I could think about 1 as 1 over 1. And then I could multiply this diagonal, x squared minus x, equal to that diagonal. And now move everything to one side, because that's what you always have to do. When you have a quadratic, you need a 0. And then try to see if I could factor it. If I can't factor it, I'll do the quadratic formula or use my graphing calculator to find the solutions. So the quadratic formula, the opposite of b, plus or minus b squared minus 4ac all over 2a. And then that's 12 plus or minus the square root of 144 minus 12, which is 132 over 2. And you could simplify this radical. You could get a decimal approximation for the answer. Whichever way you want to go with that, I'm fine. Using your calculator to plug it in to get an approximation. I'm not picky about the simplification of that, although sometimes StatLab is, so you want to be comfortable with being able to do that as well. If you have a fraction equal to 0, that's very, very different. Because when you have a fraction equal to 0, it doesn't matter what's in the denominator. you need the numerator to be equal to 0. So in this case, I just want to set x squared minus 4x plus 2 equal to 0. And I'm going to disregard this because I'll never make this fraction equal to 0 by looking at the denominator. In order for a fraction to be equal to 0, the numerator has to be equal to 0. So now I've got this, which again, I need to jump to the quadratic formula or my graphing calculator to figure out what the solution is. So I'm doing the quadratic formula right now. The opposite of b, plus or minus b squared minus 4ac all over 2. And I get 4 plus or minus the square root of 8. And I'll just go ahead, since this is a simple one, to simplify. 8 square root of 8 is 2 radical 2. Now here's a common mistake that I see people make. They just divide the 2 into the 4 and say they're done. You cannot do that. If the 2 doesn't divide into the 4 and this 2, we're not going to simplify it at all. Because this 2 belongs to both of these, and it has to divide into each of these. So that's why we're going to write it as 2 plus or minus the square root of 2. We're going to divide it into 4 and 2. So it is a lot of information, but hopefully it is all review for you, other than maybe this kind of stuff, factoring out negative and fractional exponents. It is crucial that you can do this. You will not be able to move forward in calculus without this skill. So make sure that you practice it and get it down.